Hi students, this is Alex here. In this video they have given there's a rectangular plate which is bounded by these lines and its surfaces are insulated and the temperature along the two adjacent sides are kept at 100 degrees centigrade and the other two edges are kept at 0 degrees centigrade, and we have to find the steady state temperature at any point in the plate. This is the first part, and also we have to find any temperature at any point of the square plate of side A if the adjacent sides are kept at 100 degrees centigrade and the others are kept at 0 degrees centigrade. Let's take a small diagram. So we have x-axis and y-axis. So this is x and this is y. So they have given it is a rectangular plate. So we take a rectangle here and here. Let's mark x-axis and y-axis, and this is y equal to 0 because x-axis, and this is x equal to 0 because y-axis, and here we take x is equal to a and y equal to b. So as per the question we have marked all the sides and two adjacent sides are kept at 100 degree. So let's keep these two adjacent sides. This is u of x comma b and this we keep it as 100. Similarly here this is u of a comma y. This we keep it as 100 and the other two sides are kept at 0. So this is u of x comma 0 which is 0 and this is u of 0 comma y which is 0. Now to solve this we are going to split into two parts because we have two values. So as a single solution it is very difficult to solve. Let's write the boundary condition for this initially. So the boundary conditions are first one, we take the bottom surface which is u of x comma 0 is 0, then u of 0 comma y is 0, then third one, let's take the top surface u of x comma b is 100, and fourth one u of a comma y is 100. So these are the boundary conditions we have, and here we should also specify 0 less than or equal to x less than or equal to a because x ranges from 0 to a. Here 0 less than or equal to y less than or equal to b, y ranges from 0 to b, and here again 0 less than or equal to x less than or equal to a, and here 0 less than or equal to y less than or equal to b. Now the two-dimensional heat equation is dou square u by dou x square plus dou square u by dou y square equal to 0. Now the solution is u of x comma t, but we are going to split u of x comma t as u of x comma y. We are going to split the solution as two parts, that is u1 of x comma y plus u2 of x comma y. So we are going to redraw the diagram as a two part, for one for u1 other for u2. So let's take it here. We have x-axis, y-axis. We are going to draw for u1, again x-axis and y-axis. So as usual we have a rectangular plate here and even here, and let's mark the axis first. This is x and y, and this is x and y, and all the surface equation, this is y equal to 0, this is y equal to b, this is x equal to 0 and this is x is equal to a. Similarly here y equal to 0, y equal to b, x equal to 0, x equal to a. And now the temperature u1 of x comma 0, this is 0, and u1 of 0 comma y, this is 0. Similarly, here u2 of x comma 0 is 0 and u2 of 0 comma y is 0. And as per the condition, the two adjacent sides are maintained at 100 and 100. So, one we are going to take 100, other I am going to take 0. That is, for the u1, I take u1 of x comma b is 100, and here u2 of a comma y, I take it as 0. Similarly, sorry, this is u1. u1 of a comma y is taken as 0. But here u2 of x comma b, we take it as 0, and u2 of a comma y, we take it as 100. So what we have done is, in 200s we have in the adjacent sides, but here we place only 100 for one side and other is 0, and in the other side we take it as 100 and other one we took it as 0. So we have separate u1 and u2, and again we have to write the boundary condition for u1 and u2 separately. So let's write the boundary condition for u1. So the boundary condition are, see here, first one, u1 of x comma 0 is 0. Similarly, u2 of x comma 0 is 0. And again that x ranges from 0 to a. That is fine. Second one, u1 of 0 comma y is 0 and u2 of 0 comma y is 0. And third one, the one which is having 0, I am going to take u1 of a comma y is 0. I have taken this part, but here I have to take the other one, top surface, u2 of x comma b. Third condition is u2 of x comma b is 0, and the 100 is top surface in the u1. So u1 of x comma b. That is the fourth condition. u1 of x comma b is 100. u2 of here a comma y is 100. So let's keep this one separate and this one separate, and we have to solve both separately, and finally we are going to give the final solution by sum of both the separate solutions. Now let's take the u1 condition and we take the suitable solution. So the suitable solution for u1. So u1 of x comma y will be a cos px plus b sin px into c e power py plus d e power minus py. We are going to use the first condition. So using first condition, which is u1 of x comma 0. So in this case, if I use the first condition, it is difficult to arrive the solution. So we have to use the second condition first. So this condition we have written in a different order, but when we use it, we have to take it in a proper order. So I have to use the second condition, 0 comma y. So this is 0. So wherever x is there, we have to substitute 0. So here, here and here. So this will be u1 of 0 comma y will be a, cos 0 is 1, sin 0 is 0. So we have only a left, and here it is c e power py plus d e power minus py. Now this value is 0. So 0 equal to a into c e power py plus d e power minus py. Now from here, c e power py plus d e power minus py cannot be 0 because it exists for all the values of y. Therefore the only option is a must be 0. So we take a as 0 in our solution. So u1 of x comma y is going to be a0. So b sin px into c e power py plus d e power minus py. Now using the first condition, but again using the first condition not possible to arrange the solution. It is better to use this one as a second. This we used already. We have to use this as a second. So using the third condition I have to say. So using third condition, which is u1 of a comma y. So u1 of a comma y is 0. So wherever x is there, I have to substitute a. So this will be u1 of a comma y is b sin pa into c e power py plus d e power minus py, and this is 0 anyway. So 0 equal to b sin pa c e power py plus d e power minus py. Now already we discussed c e power py plus d e power minus py is not 0, and again b cannot be 0 since a was already 0, because in one factor both the constant cannot be 0. Therefore sin pa must be 0. When sin theta equal to 0, theta is equal to n pi. So pa equal to n pi. So p is equal to n pi by a. So this we are going to substitute in the solution. Now u1 of x comma y becomes b sin px into c e power py plus d e power minus py. Now coming to the next one, we are going to use this condition as a third. So using the condition 1, u1 of x comma 0. So here using u1 of x comma 0. So wherever y presents, we have to put 0. So this will be u1 of x comma 0 equal to b sin n pi by ax, and c, when I put 0 here, e power 0 is 1, again d into c into e power 0 is c only, and e power 0 again, that is 1, so we left with only d, and this value is 0. So if I use it here, 0 equal to b into sin n pi by ax into c plus d. Now from this already we discussed b cannot be 0 since a was 0, and sin n pi by ax cannot be 0 because it exists for all x. So c plus d must be 0. From this d is minus c. So we get u1 of x comma y as b sin n pi by ax into c e power n pi by ay. D is minus c, so minus c into e power minus n pi by ay. So now c can be taken outside, and b into c, then sin n pi by ax, and we have e power n pi by ay minus e power minus n pi by ay. And this whole term is going to be, according to the formula, e power x minus e power minus x is 2 sin h of x. So now this is b into c sin n pi by ax into 2 sin h of n pi by y. So this BC and 2 can be combined as a constant an into sin n pi by ax into sin h n pi by ay. This is our u1 of x comma y. Let's write the general solution by taking the summation. So summation n is from 1 to infinity. We have an, then sin n pi by ax into sin h of n pi by ay. Now using the last condition, there is a fourth condition. Let's see the condition once again. u1 of x comma b is 100. So here u1 of x comma b is 100. So wherever y presents, we have to substitute b. So this will be u1 of x comma b is summation n is equal to 1 to infinity an sin n pi by ax into sin h of n pi by a b, and this value is 100. So we take 100 equal to summation n is from 1 to infinity an. This is fully constant, so I write sin h n pi b by a here. Then I write sin n pi by ax. Now I am going to give a substitution. This entire term as bn. bn is an into sin h of n pi b by a. So 100 equal to summation n is from 1 to infinity, and we have bn into sin n pi by ax. And this is the half range Fourier series. This is half range Fourier sine series, and the value of bn is, according to the formula, 2 by L integral 0 to L f of x into sin n pi x by L dx, and the length L is a here. So we take integral 2 by a, integral 0 to a, f of x is 100, then sin n pi x by a dx. After this, we are going to continue the integration, and the constants can be taken outside the integral. So this will be 200 by a, and we have sin n pi x by a. Its integration is minus cos n pi x by a whole divided by n pi by a, and we have 0 to a as the limit. So this will be 200 by a. When we use the upper limit a here, a gets cancelled. So minus of cos n pi, then by n pi by a. When I apply the lower limit, minus of cos 0 is 1. Already there is a minus. So minus 1 by n pi by a we will get. And now this will be 200 by a, and n pi by a we can take common. And remaining is minus cos n pi plus 1. So we can cancel this, and this will be 200 by n pi, and 1 minus, I have written this positive first, cos n pi is minus 1 whole power n, and this is our bn, and this exists for even or odd we have to check. So if n is odd like 1, 3, 5, so 1 minus of minus 1 whole power 1 will be 1 minus of minus 1, that will be 1 plus 1, 2, and bn will be, and there is a 200, so it will become 400 by n pi if n is odd, and if it is even, 1 minus minus 1 whole power 2, then 1 minus 1, it will become 0. So this is 0 when n is even. So we got the value of bn, but bn, from bn you have to find an, and using the substitution which we gave, I'm going to write it here. here it is. So this Bn equal to An into sin h n pi b by a. So we take that Bn equal to An into sin h n pi b by a. So from this, An is Bn by sin h n pi b by a. So if I substitute Bn here, then An will get two values, that is 400 by n pi into sin h n pi b by a when n is odd, and it is 0 because when I put Bn as 0, the total number is 0. 0 when n is even. So we got this An. This we have to substitute in our solution u1 of x comma y, which is summation n is from odd till infinity. In formula we wrote 1 to infinity, but now we have odd till infinity. An we have to copy 400 by n pi sin h n pi b by a. Let's check the solution. The solution is here. This is our solution, and we have to use the summation 1. So we replaced An along with that sin n pi x by a sin h n pi y by a. So this into sin n pi x by a into sin h n pi y by a. And from this, the constants can be taken out, and along with that, every n is replaced as 2n minus 1 to write the summation from 1 to infinity. So finally, u1 of x comma y becomes 400 by pi summation n is from 1 to infinity, and in the numerator we have sin 2n minus 1 into pi x by a into sin h 2n minus 1 into pi y by a whole division n is 2n minus 1, then sin h 2n minus 1 pi b by a. This is the first part of the solution. In the same way, we are going to proceed with the second part of the solution, that is u2 of x comma y using these boundary conditions. I copied the boundary condition of u2. Now we are going to write the suitable solution for this boundary condition. So u2 of x comma y becomes a e power px plus b e power minus px into c cos py plus d sin py. Now I am going to use the first condition. So using first condition, that is u2 of x comma 0 is 0. So wherever y is there, we have to substitute 0. So u2 of x comma 0 becomes a e power px plus b e power minus px into, when y is 0 here, cos 0 is 1 and sin 0 is 0. So we left with only c, and this value is 0. So 0 equal to a e power px plus b e power minus px into c. And here this term a e power px plus b e power minus px is not equal to 0. Therefore, only option is the constant c must be 0. This we are going to substitute in our solution. So u2 of x comma y become a e power px plus b e power minus px, and c is 0. So d into sin py we have. Now we are going to use the next condition, and the next condition which we have to use is this. That is the third condition. u2 of x comma b is 0. So here, using third condition, u2 of x comma b is 0. So wherever y present, we have to use b. So u2 of x comma b becomes a e power px plus b e power minus px into d sin pb, and this is 0. So we take 0 equal to a e power px plus b e power minus px into d sin pb. Here, this entire term which we already discussed, a e power px plus b e power minus px not equal to 0, and again d cannot be 0 since we already had c as 0, because in the same factor two constant cannot be 0, otherwise the solution becomes 0. Therefore, the only possibility is sin pb equal to 0. It means when sin theta equal to 0, theta is n pi. So this pb must be n pi. So p is n pi by b. Now we are going to use the value of p in our solution, which is u2 of x comma y is a e power n pi by b x plus b e power minus n pi by b x into d sin pb. So sin px, which is sin py, which is sin n pi by b y. Let's cross check again. So here, so we replace p and the rest of the terms are written as it is. So a e power n pi by bx plus b e power minus n pi by bx d into sin n pi by b y. Now we are going to use the next condition. So using the one which having 0 as a value, this second condition, u2 of 0 comma y. So using the second one, u2 of 0 comma y as 0. So every x is replaced as 0. So now u2 of 0 comma y becomes a e power 0 is 1 and b e power 0 is 1. So a plus b d sin n pi by b y, and this value is 0. So I am going to use 0 here. So 0 equal to a plus b into d into sin n pi by b y. Now already we discussed d cannot be 0 because c was 0, which we discussed here. Then that we can write, since c was 0 already, and sin n pi by by cannot be 0 because it exists for all the values of y. Therefore a plus b must be 0. From this b is minus a. So we are going to substitute u2 of x comma y. So a e power n pi by b y, then plus b, which is minus a e power minus n pi by b, sorry, it is x here, x whole thing into d sin n pi by b y. So we can check here. So we replace this as minus a and rest of the terms are written as it is. So d into sin n pi by b y. Now a can be taken out and this d can be written next to a, and remaining is e power n pi by bx minus e power minus n pi by bx sin n pi by b y. And we have a formula, e power x minus e power minus x is 2 sin h of x. So AD into this whole term is going to become 2 sin h of n pi by bx, then sin n pi by by. This is what u2 of x comma y, and all these constants 2AD is combined as AN. So AN into sin HN pi x by b into sin n pi y by b. This is u2 of x comma y. Now we are going to take the general solution. So in general solution, we take summation n is from 1 to infinity. We have all the terms an sin h n pi x by b into sin n pi y by b. Now we are going to use the last condition. The condition is u2 of a comma y is 100. u2 of a comma y is 100. So wherever x present, we have to replace it with a. So this becomes u2 of a comma y is summation n is equal to 1 to infinity an sin h n pi by b into a, then sin n pi y by b. And here we can take substitution. Let bn equal to, but before that we can replace the value of u2 of a comma y as 100 here. So 100 equal to summation n is equal to 1 to infinity. This entire term I take it as bn into remaining sin n pi y by b, where bn is an into sin h n pi a by b. So this is the substitution we give. But after the substitution, we find this is half range Fourier sine series, and hence we can find the value of bn using the formula 2 by L integral 0 to L f of x into sin n pi x by L dx. But here it is a function of y, so we have to take the length as b, 2 by b integral 0 to b, and f of y, which is 100 here, and this will become sin n pi y by b dy. So the constants can be taken outside, which is 200 by b, and integration of sin is minus cos n pi y by b by n pi by b, and we have a limit from 0 to b. So this becomes 200 by b into n pi by b. We can take out common, this gets cancelled. When I put the upper limit for this, bb gets cancelled, so minus of cos n pi, then minus, when I put the lower limit, minus of cos 0 is 1, so we get minus 1. So totally this is 200 by n pi, and this will be 1 minus cos n pi. So this is our bn, and from here we can take the cos n pi as minus 1 whole power n. So this is 200 by n pi into 1 minus of minus 1 whole power n. So when n is odd, like 1, 3, 5, 1 minus minus 1 whole power 1, 1 minus of minus 1 plus 1, so it becomes 2. So the value of bn is, when I put 2 here, already this is 200, so 400 by n pi, then n is odd, and suppose if n is even, like 2, 4, 6, 1 minus of minus 1 whole power 2 will become 1 minus of plus 1, it will become 0. So it is 0 when n is even. And already we gave a substitution. So already we have given a substitution. Let's copy the substitution here. bn equal to an into sin, it's here, h n pi a by b. So sin h n pi a by b. So now from this, an equal to bn by sin h n pi a by b. So an will have two part now. Bn value is 400 by n pi when n is odd and Bn is 0. So when I put 0 here, the total value is 0. Actually, I have to write the sin h n pi a by b also here. Let's write along with this denominator, that is sin h n pi a by b when n is odd and it is 0 when n is even. So we got an. So this we are going to substitute in our solution u2 of x comma y, that is summation n is from now odd till infinity. An I have to copy, which is 400 by n pi sin h n pi a by b. So here is that solution. Let's highlight it. So an we substituted sin h n pi x by b. So let's write that down here into sin h n pi x by b into sin n pi y by b. So this odd can be changed from odd to infinity as 1 to infinity by changing n as 2n minus 1. So we are going to replace every n and at the same time we are going to take the constants also outside. So u2 of x comma y becomes 400 by pi and we have summation n is from 1 to infinity. In numerator we have this term, that is sin h 2n minus 1 into pi x by b into sin n is again 2n minus 1 into pi y by b, then whole division n is 2n minus 1 into sin h, then 2n minus 1 into pi a by b. This is the second part of the solution. Now the final solution, u of x comma y is made up of u1 of x comma y plus u2 of x comma y. So we have to combine both the answer and give it here. So that will be u of x comma y is first part is, and second part you have to write plus here. So this combined together gives the complete solution for the given problem. In the question, they have also asked for another part, that is if it is a square. So I just highlight and show. Also find the steady state temperature at any point of a square plate of side A if two adjacent edges are kept at 100 degrees centigrade and the other at 0 degrees centigrade. So already we have completed the problem for the rectangular plate. Now for the square we can just change all the B as A, because in square all the four sides are equal. So if it is a square plate, so we can write here for square plate A equal to B here, that is all the B is also A. So if I take a small rough diagram, I am not going to write any boundary conditions, just for reference only the diagram. So we have a square plate like this, so everything is A. So we can use this same solution and change all the B as A. So I am going to copy this solution here and going to change every B as A. So wherever B is there, I can change as A, then this AA gets cancelled. So I am not writing that A itself. So AA gets cancelled. So we don't have denominator term here. Similarly, even here, this B is A, this B is A. So this is A, this is A, and even this B is A, but A gets cancelled, so we have only this much. So this is our solution for the square plate of side A, where two adjacent edges are maintained at 0 degree centigrade and the other two sides are maintained at 100 degree centigrade. So we derived for the rectangle. The same way we can continue from the beginning, but since already we have a result of the rectangular plate, we can just change the B as A and get the final solution for the square plate with side A.